So now we are going to continue looking at graphing cumulative distributions. But in this case, we have a range of data values. So we're looking at 80 athletes are running laps around the track. We have the grouped frequency table. And what we want to do is we want to construct that cumulative table for this data. And then we're going to use that in turn to draw a cumulative frequency curve for the number of laps run by the different athletes. And then we're going to use that curve then to estimate median and interquartile range, a little bit of what we were talking about yesterday. So with this information, when I start looking at my cumulative frequency, so I have my frequency here, so now my cumulative frequency, so initially it's 1, so 20 plus 1 is 21, and then 21 plus 31, so 52, and 52 plus 21 is 73, and then 73 plus 7 is 80. So now what I'm going to look at is I'm going to be graphing for those x values these cumulative frequencies. Okay, so I'm going to go ahead and make my table or my graph. For my x-axis, I'm going to have the number of laps run. And then on the vertical axis, I'm going to have the cumulative frequency. And then scaling it, my x-axis I can count by 2s. So 2, 4, 6, 8, 10, and then keep going all the way across. And then for my vertical axis, I'm going to count by 5s. So I'm going to skip and count by 10. Okay, so now what I'm going to have you do is take your laps with the cumulative frequency and go ahead and plot the points. Keep in mind by the end of the group frequency, so by 10 there was 1. By 20 there was 21. So we're always looking at the ends of them when we start putting our dots, because we don't know where the data fell in between there, but we do know that by the end, by 20, there were 20 more folks that ran. Okay, so pause this for a minute and go ahead and plot those points. So now that we plotted the points, we have this nice little curve. One of the things that you can look at, and it's sometimes hard to see, like, where should I start? Because it did go from 0 to 10, there was 1. So since there's a cumulative distribution, by the time we hit 10, there was 1. We don't necessarily know what other kind of information. I mean, we could, in essence, put like an open dot at 0, and then we could draw our little curve in there. You need to be a lot more accurate than that. I'll fix this to make it more accurate. But that kind of gives you the S shape. But what I'm going to end up doing is I'm not going to connect it back to 0, 0. And I'm just going to start at the end of this value and then curve it. Okay, again, I'll fix it. I'll make it better so it goes through those points. Okay, there we go. So with that, I have to have a nice smooth curve, because what we're going to now do is we're going to anticipate what they were asking for. So they want us to find the median, they want us to find the IQR, and we're going to be able to find percentiles and such, and I'll go through that in just a minute. So with this data, if I want to find the median, I know the median is half of my data. So there were 80 different people that ran. So therefore, half of that, obviously, half of 80 is 40. So what I'm going to do is I'm going to draw a horizontal line at 40. And I'm going to draw it until it hits my shape. And then what I'm going to do is I'm going to drop a line from there straight down so that we can see how many laps the median actually was. So how many laps they actually ran. So for my median, when I look here, so this counted by 2, so 20, 22, 24, 26. So that looks like 27. So my median looks to be 27. Now please know there's going to be a little bit of leeway because you drew the graph and you drew the lines. There's going to be some error. Now if you didn't draw the graph, you should have a better approximation of what the value is. So on an IB test, a lot of times what will happen is they'll either have you draw the cumulative frequency graph, or they'll give you the cumulative frequency graph and then they'll make you draw your perpendiculars in. Okay, so that way it's accurate and there isn't a lot of error. Okay, so that's my median. They also wanted me to find the interquartile range. So if I need to find the interquartile range, what do I need to find? Q1, Q2. So Q1 is the bottom quarter of my data. So it's the half of the half. So if half my data was at 40, half of that then would be at 20. So I'm going to go ahead at 20, draw my line. Oh, that's not a line. Let's try that again. Okay, and then I'm going to stop, and then from there, I'm going to drop. So therefore, Q1 looks like it is at 19, close to 20 maybe, but I think it looks real close to 19. And then Q3 is going to be at 60. Bringing that line across, dropping it. Oh, that's a nice one. That's right on a line, it looks like. So therefore, Q3 looks like it's at 32. Now again, keep in mind these are all approximations, so we're going to be slightly off with our information. Even when I made it on my piece of paper, I had different values than what I have up here. Only one of them was, actually 2 of them were different. So please know that there will be a little bit of skewedness along the way. So to find my IQR, that is Q3 minus Q1, which is 32 minus 19, which is 13. So my interquartile range is 13. So that's how we find our 5-number summary as well. We could do a box and whisker plot, but using the cumulative frequency, I can find other information as well. So it goes both ways. I can take my data and find all that information, or I could use my data and graph it and then find that information from it as well, knowing that there is going to be that leniency in there. Now, the other thing that we can use this for is to find percentiles. So for percentiles, it is just a number where a certain percentage of scores, whatever the scores would represent. So in this case, it would be the number of runners. So the scores fall below that percentile. So you usually hear percentiles when you start talking about standardized tests and where you fall in relationship to your peers. So it's all dependent upon the data that's collected. So for instance, a 50th percentile, that's the median. The 50th percentile is just the median. So if I wanted to look at the 50th percentile, so 50% of my data is 40, so I'd bring my 40 over and drop it down. So an example of this, maybe we use the 60th percentile, just so we're using a number we haven't used yet. So if I want to find the 60th percentile, that means I'm better than 60% of the other folks. So all I need to do is take 80 and multiply it by 60%, so 0.60, which gives me 48. So now what I do is I go over to my graph and I draw a horizontal line at 48. And then I drop my perpendicular. So therefore, that looks like if I was in the 60th percentile, that looks like I ran approximately 29 laps. So if I was in the 60th percentile, I ran approximately 29 laps, because I think that's 30. Okay. So that takes us with cumulative frequency, and then again, combining it together with what we've been doing. Moving on to the last type of measure of spread is variance and standard deviation. Variance is a subset of standard deviation. So it's what you get right before you get the standard deviation. But technically, variance is going to take all, so it combines all data points. To give the data spread. About its mean. So what you had before when we were looking at different measures of spread, when we were looking at the interquartile range, we were just looking at the data points between quartile 1 and quartile 3. When we're looking at the range, all we're looking is the max, the min. We're not looking at any other points along the way. We're just looking at those specific ones. So it kind of limits what we're looking at. Now, don't get me wrong. Those are all still really great things to look at, but it skews things because we don't know what else is happening within those data points. Whereas with the variance, we will use every single number to compare what we know about the mean. Okay. We're looking at how far from the average each one is. That's where we're talking about the spread of its mean. But what ends up happening is variance. So like if I was talking about feet, when I find variance and I find the distance from the mean, I'm not actually finding feet. It's in relationship to square feet. Because what ends up happening is I have to square my differences. So we use variance, but then standard deviation helps bring that back to more of a normal typical unit measurement. So if I'm looking at feet, it's giving me my idea in feet. It's not going to be square feet. So standard deviation is just simply the square root of the variance. So what ends up happening is you find the variance first and then you square root it. Okay, and students sometimes get that mixed up. You're going to first calculate the variance, and then all you're going to do is square root it, and that's going to give you the standard deviation. So some things to know about standard deviation. So one thing is, as kind of stated above in variance, it's the measure of spread around the mean. Of data. So it's the measure of spread around the mean of the data. The second thing, it's never negative. We end up squaring the differences to make them positive. Otherwise, if we didn't, we would just get 0. And then it's very sensitive to outliers. So sensitive to outliers. So if there is an outlier, it's definitely going to skew your standard deviation quite a bit. And then the last thing, if data is similar, with the means, so if the data means are similar, then if the spread is greater, so if it spreads out from the mean, the standard deviation is greater. So again, if the means are similar, then the spread will be greater and the standard deviation will be greater. So if the spread's greater, standard deviation is greater. So this is a way to look at it. So this darkened one, this has a low standard deviation. So all of your values are really close to the mean. They're kind of smushed close to that mean. That's why it jumps up really high quickly. Whereas, so it has a low standard deviation. Whereas if it has a high standard deviation, it spreads out the data more from the mean because the mean is going to be right in the middle. Okay, we're looking at that center piece. So if it's a low standard deviation, so if my value for standard deviation is like 1 or maybe 0.5, it's going to spike right in the middle because everything, all the data is really close together. Whereas if I have a high standard deviation, like maybe my standard deviation is 10, then everything's really spread out from that mean. Here's how we calculate it. Very mathematical notation. So we're going to look at the population standard deviation and the population variance. Again, it is different between population and sample, which is why they use mu, but we're going to use x bar for our mean. So technically, It is mu, but again, we typically use x bar for the mean. So what it's doing is it's taking the sum of all of your x values minus the mean and squaring them. And it adds all of those together and then it divides by n. That's variance. Then you square root it and now you have standard deviation. So the bottom is just no square root. So the sum of the differences between each data point and the mean, what we're going to do then is we're going to take that value and square it because they're going to be positive and then others are going to be negative. So therefore, when I add all those together, I get 0 because half of them are positive. Well, not half, but the numerical values are positive and then the other ones are negative, which means that they're going to be 0. So we're going to square those differences. And then we're going to divide it by n, which is however many values that we did. And that gives you population variance. That gives you the variance. So notation for variance is sigma squared. So that's lowercase. So it looks like this, circle with a top on it, and then square. So that's standard deviation. That's variance. So if I give you the variance, all you need to do is square root it to get the standard deviation. Or if I give you the standard deviation, all you have to do is square it and get the variance. If they ever ask for questions within there. Okay, let's actually do a practice with this. We're going to need this data for later on, so I figured we'd practice it with that. That way we don't have to do it again. So what I'm going to have you do is I'm going to have you calculate the mean and the standard deviation for these 10 numbers. So go ahead first, calculate the mean, and then I'll walk you through a nice way to organize it to help you find the standard deviation. Okay, so double check your mean. So now what I have to do is I have to take all my data points. That's what these x sub i's are. I'm going to take all those data points and subtract my mean. So to organize this, my recommendation is set up a table. So I'm going to, that's not a very straight line. So I'm going to do a column of all my x's. So I'm going to write every x, 0, 1, 5, 8, 15, 15, 20, 22, 25, and 39. Okay, so those are all my data points. Now, if we have a bunch of them that have frequencies like this, I'll show you how to do frequencies as well. Then I'm going to take my value and subtract the mean from all of these. So that's going to be my next column here. So it's 0 minus 15. So negative 15, negative 14, negative 10, negative 7. These are nice zeros. 5, 7, 10, and 24. So I found all the differences. Again, some smaller, some bigger. When I add all those up, I should get 0. Some are on the positive side of it, some are on the negative side of it. So now what I have to do is I have to make all of those values, all those differences, and square them. Because now what's going to happen is it's going to make all of them positive. That way I can actually see how far from the mean we are. Again, in the column, I can see those top 4 are on the bottom side of the mean. So they're on the left side, whereas the top 4 are on the right side. Now I'm going to get all of them so that they're positive. So that way I can look at how far apart we are from each of the means. So I square each of these, and that's 225, 196, 100, 49, 0, 0, 25, 49, 100, and 576. So from there, what I have to do is I had to sum all of those up. Again, that's what's in that top of the fraction. So now I'm going to sum all of those up. When I do that, I get 1,320. So therefore, my variance, sigma squared, is 1,320 divided by 10. I'm averaging the squares of my difference, of the squares of my differences. That's what I'm doing right now, is I'm averaging them. So I'm seeing how far away they are. So therefore, my variance ends up being 132. But again, because I have that squared, it's like feet squared in essence. What I want to do is I want to bring it back down. I want to bring it back down to that label that it initially started with. So therefore, I have to square root that to get my standard deviation. So when I square root 132, I get about 11.5. Rounding correctly, it's 11.489. So what that's talking about, that's the variability of all of my data points. Okay, so I'm finding, on average, how far are my points away from the mean, where my mean is 15. That's what I just found. How far away my data points are from the mean. That's how we calculate standard deviation. So now what I'm going to have you do is you're going to do this investigation. In this investigation, we already did B. So you can just find your information from the previous and substitute all of that in for your player B. But what you're going to be doing is a coach has 2 basketball players who in the last 10 games have scored the following points for their team. So player A scored 12 points, 13, 15, etc. Player B had 1 game where he scored 0 points, a couple games where he scored 15, 1 game where he scored 39 points. So what I need you to do is I need you to fill in this table. And so based on the performances from those last 10 games, I then want you to analyze who should the coach pick if he wants a reliable point scorer to start the game. Who should he choose and why? Situation 2, his team is down by a whole bunch of points with 10 minutes to go. Who should he choose and why? And then the last part is, what do we have to take into consideration when we compare 2 sets of data? Because these 2 sets of data are quite different. So pause the video, please, and go ahead and calculate each of these pieces. So what you'll notice, they both scored exactly the same number of points. They both have the same mean and the same median. Their ranges are quite different, so maybe you can make an assumption based on their ranges, and then their standard deviations are also quite different. So if you need a reliable point score, who are you going to choose? Well, since the total points mean and median are all the same, or even if they would be close, based on the fact that the range is small and the standard deviation is small, this player is very consistent with shooting. So this would be player A's perfect position. Okay, put him in, he's a consistent shooter, he's going to more or less score the same number of points. However, in situation 2, so part 3, the team's down by 17 points with 10 minutes to go. Who should he choose and why? Now, in this case, player A consistently is scoring right around that same value. None of those, besides the 1 game, is he scoring 17 points. However, player B in this case, he has more variability. If you look at his range, you can see just from high to low, but even within there, you can see he has these top end numbers like 20, 22, 25. It's not that he just had 139. You wouldn't see that if you didn't do the standard deviation. The standard deviation is a big number, which means it varies a lot from the mean. So this is a player who is more likely to be able to have a high scoring game. Okay, yes, he's had some bad ones, but player A is not going to get you there. He's not going to be able to get you that large chunk of points based on past practice. So then what factors do you need to take into account to compare the 2 data sets effectively? You need to compare both the center and the spread. So we've looked at measures of center, looking at your mean, median, and mode, but now we also have to look at that spread. How spread out is it? Not just max to min, but now also in average. So that's where that standard deviation comes in. The last part of the new lesson comes from, we did very similar with measures of center. Now we're going to compare it to spread. So data set has a mean of 12 and a standard deviation of 2. Okay, so we have our mean of 12 and our standard deviation of 2. If each value in the data set has added 20 to it, what's the new mean and standard deviation? So the new mean, all I'm doing is I'm translating the data. I'm moving all of the data 20 units to the right. Nothing's spreading out at all. All the spread is still the same. So therefore, my mean is still going to be 32, and my standard deviation is still going to be 2, because nothing is stretching out away from it. Everything just simply shifts to the right. Versus in B, if I'm multiplying my data set by 4, now we're going to find the new mean and variance. We'll do the standard deviation first, and then we'll do the variance. So now I'm multiplying everything by 4. Since I'm multiplying everything by 4, what I'm doing in essence is I am stretching it out horizontally. Since I'm stretching it out, since I'm multiplying it out, my mean now is going to be multiplied by 4. So my mean is going to be 48. My standard deviation, my spread, is going to be different as well. So my spread before was 2, but now I've gone out even further. So now my mean is going to be 48, and then my next data points are going to be spread away from that, which means I'm going to have to multiply also my standard deviation by 4, which means my standard deviation is 8. Now we're trying to trick you because here we stated variance. So what is the relationship between standard deviation and variance? variance is squared. So variance is standard deviation squared, which means my variance would be 64. Okay, the last part then that I want to go through, I don't have any other notes for you, but what I want you to do is I also want you to be able to calculate the standard deviation with your calculator. So you've already done the mean in your calculator. Now we're going to do standard deviation in there as well, and we're going to use these data points. So real quickly, I'm going to go to our calculator. Keep in mind we turned our plot on. You are going to want to turn it off. You can just arrow up, hit enter, and arrow down. Now your plot's off because I don't really need to plot these points, but just in case you need to graph anything. Okay, so I'm going to go into stat. I'm going to edit. I'm going to clear this list. And then I'm going to put in all my new data points. So, just to find my numbers. Okay, so we have 0, 1, 5, 8, 2 15s, 20, 22. Oops. Always double check those. 25 and 39. Don't forget enter after the last one. Okay, so now what I can do is I can go back to my stat, and I'm going to go over to calculate one variable statistics. I have no frequency, so I'm going to calculate this. And then it tells me right here my mean is 15, so that's perfect. And then my standard deviation is this one right down here. This is sigma. Please make sure that you understand this is the one that we're always going to use. This is the population one. Okay, so that's what we'll use for our standard deviation, and then we also have all the other pieces of information if you needed those as well. A quick side note for you as you guys do your homework problems. One of the things that could happen is you could have a frequency piece in here as well. If you end up having a frequency, all you need to do is you can add a column in here. That's the frequency times x minus x bar squared. Okay, and so that way, like if I had a frequency of 1 and there were 3 of those and 5 of these, then I just can take that 3 and multiply it by the 196 and put it here. Okay, so that is just another step into it, just kind of keeping track of it, and that's where organization is going to be really helpful. If you try to put it all into your calculator, first off, you're not going to get points for doing it. But secondly, you're going to miss things as well. So take your time on it. I'll assign limited problems because of that. So the homework problems that I have for you to do with this lesson are 6I, numbers 1B, 2A, and 5, and then 6J, numbers 1, 3, and 4. Again, I'm trying to limit the number of problems that you're doing. If you need extra practice on this because you're just not 100% confident, pick any of the other problems. I'm picking these because they give you a nice sampling of them, but there's a lot of other ones that are good in there that'll give you some good practice. Okay, good luck.